Okay, this is my circuit. As you can see, currently it is up. So if I just press the button, the 1, 2, 3, 4, 5, 6, 7, 0. No, totally fine. If I go down, which is just by pressing this, so the NOT gate will make it down. So it's in down count right now. So basically, it goes from 0 to 7 to 6 to 5 to 4 to 3 to 1, 2 to 1 to 0. Right? And if I just do anything and I just click reset, it always gets to reset because that's what reset does. It kind of just clears the whole data stored in the system. So how does this thing work? Well, first I think I have made an innovation. So for the last digit, the least significant digit, as you can see, I didn't connect it to up or down. I just connected the input to the complement of its output, right? Because I think that no matter it's up or down, the last digit would always change, right? So there's no point of, as the diagram show, connected to the up or down and then use another or XOR gate. You can just use none of these and just make sure that whenever you click it, it always changes, right? So I think that definitely saves some circuit components, and that's something I guess we should always try to do. What about for the rest of the digits? Well, if you really think about it, when does a digit change? Well, it checks the previous digit. It checks if the previous digit has a carry or does it borrow one. So basically, if it is an up count, right? If it's an up count, which it goes to here, and then if it also has a output of 1, right? If we AND these two, then that means it has a carry. So we have to change the current digit, which is the second digit. Now, if the current digit, if the previous digit is 0, which means its complement is 1, right? It goes to here. And then if the down count also is 1, so we're going down counting, that means that we're counting down from 0, so we need to borrow 1 from the previous digit. So we also have to change these, right? These are the two circumstances that you have to change the current digit, judging from the previous digit. So you connect these two ends with an OR. And then, so now you know that you have to change the current digit. You just check what digit is here, right? You put the current data of the digit here and do an XOR gate. So if you know it's going to change, then if this is a 1 and this is a 0, then it gets changed, right? Because it's going to get changed. Well, basically XOR just does the change thing, just compares with the current digit and change. So similarly to the third digit as well, but instead of just connecting the up and down with the AND gates, you actually connect the previous results of the AND gates to the AND gates here. Because remember, when you're trying to change the third digit, both the previous two digits have to carry or borrow. So you just literally use what's before, right? The AND from before, and then just connect these to or to these, so that you make sure that all of the things previously are borrowing or carrying, and then you just end these with a complement or the complement or the actual output to these AND gates. And the similar process, you do an OR gate, and then you do an XOR gate that compares it with the current output and then change it. So that's how it is. I think I kind of explained it slowly, but basically that's how this circuit is. I kind of draw it too messed up, but it's you can see quite well what it is doing.